Okay, so what we're going to do for section 4. Now, we actually previewed this a little bit yesterday when we were going through everything here. So let me kind of back up for just a minute and show you some of the stuff we did yesterday. First equation we're going to do. We'll do 5 plus x over 6 equals negative 2. And for this one, similar to one we did yesterday with the fractions part of it, and we'll show you how we can do something a little different from what we did yesterday. But anytime if you get a problem and you're not sure and you've got a fraction like this one is, you can always take this thing and multiply everything by, in this case you've only got one denominator, so you could take everything and multiply it by 6. You can multiply the left side by 6, and you can multiply the right side by 6. And for this problem, if you do that, on the left-hand side, the 6's are going to cancel each other out, which is kind of what we want, because now that part of the fraction is gone. And if you do negative 2 times 6, well, that's just negative 12. Now you're back to just a one-step equation to kind of solve this thing to get the answer that you're looking for. You've got 5 plus x, so we've got to get rid of the 5. So let's subtract 5 off both sides. So x will wind up being negative 17. Okay. Now I think that was the last thing we were talking about yesterday, that especially if you get some fraction. Now, this one wasn't too bad, but the one we looked at yesterday had 3 fractions in it. How you can multiply by the least common denominator to get rid of all the fractions. You can actually do that with the problem that we did yesterday. You don't have to write this one down. You just kind of watch this one. I think the very first solving the problem we did yesterday, we did one like this where it was, I think this was the problem that we did. Again, you don't have to write this one down, you'll just kind of watch it. But yesterday what we did was we subtracted 2 from both sides, and then we went back and multiplied by 4. This one, if you kind of think back to the fractions we were talking about, you've got 4 as your one denominator. You could kind of do that one like we did at the end of class yesterday. You could take 4 and multiply it by everything in this equation. So you could take 6 times 4, you could do this times 4, you could do this times 4. And what that's going to do is it's going to cancel out this 4. So now you've got whole numbers again. And again, we talked about it yesterday, and I know we solved this one a little different way yesterday, but it's one option you can see. Okay, and then from here we would subtracted 8 off both sides, and we got x equals 16, which was the same answer we had yesterday. So, there's more than one way to do a problem. It's just a matter of, sometimes people just don't like the fractions at all, and you want to get rid of them. And there's different ways to do that to kind of make it work out there. But that was just kind of one little thing that we did yesterday. Okay. Let me show you one more, and then we're going to show you the second thing that we're looking at for today, just to kind of get us through everything here. I'll show you a little bit longer equation and work through this thing just to kind of make it all work out. Okay, so for example 2. Let's go with 3n minus 5 equals negative 8 times 6 plus 5n. This one will be good because it's got a little bit of distributive property like we did yesterday on one of the problems, but at the same time we're also going to have to move some variables around to get this thing worked out to be the right way. Okay, first thing you have to do is you're going to have to do distributive property. Get rid of that parentheses, so now you've got negative 48 and negative 40n. Right, and if it's been a while since you've done some math, if it's been a year or so, just remember that when after you've done distributed property, because that's only on the right-hand side, everything else, once you've gotten rid of all the parentheses, it's almost like a level. It's almost like a balance. That if you're going to do something to this side of the equation, if you're going to add or subtract something over here, you're also going to have to add or subtract something to this side of the equal sign. So from here, you're going to start moving your variables around. You've got 3n over here. You've got a negative 40n over here. You've got to get all the n's to one side and all the numbers to the other side. And it really doesn't matter which way you go. But for me, I kind of like, if you've got a positive n and a negative n, I tell people get rid of the negative first. And they're like, but I don't like negatives. Well, exactly, because if this is a negative 40n, to get rid of it, you're going to add 40n to this side. And then you're going to add 40 over here. So if you get rid of the negative first, we wind up actually adding. So that's kind of the first thing you want to do there. Okay, so this one, you get 0n, which is just 0, so it's gone. 3 plus 40 makes that one 43n. Minus 5 equals negative 48. And then from there, only two things to do. We've got to get rid of this negative 5, so we'll go plus 5. So now you got 43n equals negative 43. And if we're doing test questions and I'm asking you to show work for some partial credit along the way, when y'all get to the last step, you don't have to show this step because from here you're just dividing it out anyway. So that's just n equals negative 1. If you want to go ahead and show that last step, that's fine. If not, I'm good with that too, because usually that last step, it's either multiplication or division, or addition or subtraction. So usually you don't have to show anything on that last step of the problem that you're looking at. Okay, so that was kind of going back to what we were doing yesterday with some distributed property stuff. Oh, that from here, once you've got the 43n and 43, just divide both sides by 43. Yeah, and then you got your negative 1 right there. Yeah. Okay, now here's where they're going to ask you to, and we'll kind of set this up here for this part of it. Here's where you're still going to solve equations, but they're going to kind of give you a little different title when you're going through this thing. Is they're going to ask you to determine if the equation is always, sometimes, or never true. And it's basically like your three choices. It's either going to be, when you're setting these up, you're still solving equations, but it's a little bit different because they're going to ask you to pick one of these three answers. So, and here's what you have to do for one like this. Okay, very first thing you're going to do, step one, is you're going to go ahead and solve the equation. So it's still solving equations, but it's solving equations with a little twist to it. After you solve the equation, then you've got to kind of look at it. And this is where you've got to kind of dig into it and figure out exactly what's happening with it here. So here's the 1A part of it. If you wind up having a variable in your answer, then it's going to be sometimes true. Hey. Yeah. Good, how you doing? So if you're working through a problem and you solve it and you get, you know, x equals 4, or you get y equals -5 or something like that, then it's going to be sometimes true. Because, and this is the one that usually sometimes throws people off, and it's one of those you just have to almost memorize it. Because some people get thrown off because they're like, but I got the answer, it's x equals 4. Doesn't that make it always true? Well, it does as long as you plug in 4. If you plug in 3 for x, it doesn't make it work out. If you plug in 2, it doesn't make it work out. So the sometimes part is that it really only works for this one. Anything else, it doesn't work. So it's kind of a weird thing to kind of get through. And the other two that really wind up making more sense to it, the B part of it. So you're going to solve the equation, and it's going to be one of these three things, and you got to figure out where that answer fits in one of these three things. The B part of it is that if you solve it, the equation, if you don't have a variable, and you have the same number, and it's equal to itself, it's going to be always true. And here's what makes this one kind of stand out, because when you're going through this thing, you're going to solve it, and all of a sudden all the x's are gone, or all the y's are gone. And you're going to get to the end, and you're going to have 0 equals 0. And some people go, well, doesn't 0 always equal 0? Yeah, it does. So that's why they call that always. You know, it may be that you get like 8 equals 8. You know, or you may get -10 equals -10. And now basically here's what it is. This is the same thing you did before, but in the older sections of algebra and way back when, this is what the same answer is. Infinitely many solutions. So that's what it was back in Algebra 1. Probably did that when you were back in 8th grade math or 7th grade math. If you were solving equations, it's the same. Sometimes they let you just put IMS for short. So that's basically the same thing as infinitely many solutions, because it's basically saying, all right, they kind of gave you a trick question where they gave you the same thing equal to itself anyway, and you just had to kind of work it out. All right, and then the last thing, which was the part C here, if you don't have a variable, and you have two different numbers, then it's going to be never true. So if you're going to solve an equation and you're going to get 0 equals 8, and you're going to go, well, 0 doesn't equal 8. It can't equal 8, right? So if it's not able to equal that, then it's going to be never true. You know, you might get -2 equals 10 or something like that. You know, you could get -3 equals +3. And this back, again, before we're doing this class, back in Algebra 1 and everything else, this was always just no solution. Okay. Now, the good news is once we get past the first chapter, when we go through these, you really don't these things will pop up just a little bit with the no solution, the implemented solution, or as they call it, always true and never true. But really, once we get past the first chapter here, it's just regular solving equations. You get x equals something, you get y equals something. This is just throwing it out as a possibility that, these things can happen. So just be on your toes when something like this goes. All right, now here's more of what it's going to look like when we're going through the homework and going through the test question. Is they're going to give you an example and ask you, okay, is this one always, sometimes, or never true? Okay. So it's going to be like a regular equation, but again, they're just going to, instead of just saying solve it, they're going to tell you determine if this thing is sometimes, always, or never true. So it's still just solving equations, it's just a little different version of it. And for this one, again, you don't have any distributive properties, you don't have to worry about doing anything there. Now you can just start moving the terms around. And again, if it helps, you can always go back and draw a line through your equal sign. That now you're going to start moving stuff around. Well, if you want to get rid of this negative 4n, we can add 4n to both sides. So that'll make that 0n. If it's 0n, that means it's just 0, so it's gone. 4n plus 4n is 8n. Okay, and then from here you've got 8n minus 12. Well, let's get rid of that 12 and add 12 to both sides. So we've got 8n equals 24. And if we've got 8n equals 24, just got to divide both sides by 8. Now, I think in the homework, it's pretty much, I think this is the last 3 or 4 questions is this way, that we've got n equals 3, so we've actually got an answer. But again, that only works if it's n equals 3. Anything other than 3, this answer doesn't work. So beside this, you're going to have to go back and tell me, all right, this thing is sometimes true. And that's kind of the hard, that one it seems like it's hard to get because they're like, well, why is it sometimes? Because I got the answer, and I'll get that same answer every time. Yeah, but that's the only answer that works. Everything else doesn't work, so you can only use n equals 3 for that thing. So this one, it's solving equations with a twist. You still solve the equation, and then at the end, you tell me, all right, what kind of answer is that? Is it always, sometimes, or never true? So it's just making you go that one extra step here. All right, so let's do this one. Let's do negative 6y minus 3 equals 3 minus 6y. All right, same thing with this one. We got to move some stuff around. You've got a negative 6y over here. So if we add 6y to this one, that'll make that 0y, which means it's just gone. Add 6y on the left-hand side. You've also got to add 6y on the right-hand side, which also means that this one's also gone. So when both of those are gone, you're left with negative 3 and positive 3. Does negative 3 equal positive 3? It doesn't, right? So it's no. Now, again, last year you would have just put no solution or not true. Now they're saying, all right, well, instead of just saying that, now you're going to say that this thing is never true. Because there's no way that negative 3 is going to equal positive 3, and if that's not possible, then it's never going to be true. No matter what you do to this thing, you can never make this thing turn out to be true. All right, last one. make this one kind of a long one where we have to do a little bit of work to get through everything here. Actually, let me start on another page. Alright, let's go with 3 times y plus 3 plus 5y. Negative 4 times negative 2y minus 1 and then plus 5. So, kind of a long equation. Some of the ones that we're working through in the homework, they'll work up to where you've got some longer than like this. So I'll give you one of these where you can at least kind of walk through and see everything that's happening here. Alright, before we do really start moving stuff around, you've got 2 things you have to do. You've got distributed property here, and you've got distributed property here. So let's get those 2 things out of the way first. 3 times y is 3y. 3 times 3 is 9. We didn't do anything with that 5y yet. It's just hanging out there. Alright, you've got, now here's where you got to be a little bit careful. Negative 4 times negative 2, that's a positive 8 or just an 8y. And remember, when you do the negative 4 with this one, it is negative 4 times negative 1. So if you do negative 4 times negative 1, that's going to make it a positive 4. And then we got the plus 5. Alright, now once you've done distributed property, you've got everything kind of taken out, you've got it just down to numbers. That's where you can kind of go back and start looking at splitting this thing up on the left and the right. Alright, now here's where you've got 2 options. And again, this is where sometimes people do it a little different, and if you do it this way, this is fine. But let me show you one way you can do this one. If you get to the point where you've done your distributed property, if you've got 2 of the same thing, 2 variables on this side over here, you can actually kind of rearrange these terms and move this 5y up beside the 3y and put the 9 back here. And go ahead and do 3y plus 5y and make that 8y. So, and again, this is kind of going back to some things you've done in the past, that if you've got a lot of stuff on one side of the equation, you can, if there's more than one like term on one side, you can put those things together without having to add, subtract, and move to the other side. In a second, I'll go back and show you one option you could do, but this is one option you can do here. Alright, and if you kind of go to the left-hand side, you've got 4 plus 5 together right here, so go ahead and just make that 9. So really, we've got 8y plus 9 equals 8y plus 9, and maybe you're going, well, wait, that looks a lot like the same thing. Well, it actually is. Because if you subtract 8y, that makes that 0y, which is really just 0. Which leaves you with a 9 over here. That's going to give you a 0y, which is really just 0, which gives you a 9 over here. So does 9 equal 9? All the time, right? So, yeah, if it's the same thing equal to itself, your real answer is going to be, you're going to tell me that thing as always. There you go. Okay. So that's what they're looking, when they give you those 3 options, they're really making you solve equations. But then when you get to the end of it, they're saying, all right, now tell me what category does this thing go into? Is it a sometimes, is it always, or is it never true? And just kind of figuring out what's going on there. All right, now let me kind of back, and you don't have to write this down, but let me kind of back up for just a second. Because in the past, I've had people that they would do this problem, and they'll come back and ask me, and they're like, well, you know, once we did distributed property here, somebody would ask me, they're like, well, could I take this 5y and subtract 5y from both sides right here? Absolutely. You know, you can make that 3y plus 9 equals 3y plus 4 plus 5, and they're like, well, I'd rather just move things one piece at a time. You know, now I'd move this 3y over here, you know, to subtract it from both sides and get 9 equals 4 plus 5, you know, and then I would subtract this 4 from both sides. I'm like, okay, that's fine. You know, did a little bit different, but you still came back with the same thing equal to itself, so you're still going to get always true. And sometimes people, they'll forget to combine like terms. If they don't combine like terms like we did here, that's fine. If you take it one piece at a time and work it out, it's still okay. So that's what I'm saying. You don't always have to do it one certain way. This is one where you can just, if you don't want to combine like terms, if you just want to start moving one thing to one side and one to the other, that's absolutely fine. You can do that and still come up with the same answer when you're going through these. As long as you get the same number equal to itself, there's all kinds of different ways you can get there and still get the right answer out of it. So, that's just one option you can do. You can move it in one piece at a time and still be okay and get the right answer for what you're looking for. Okay, so that was the second thing out of section 4. The one last thing we've got to do, and this is where it's more like a chemistry problem, is they're going to ask you to solve for a specific variable. So this would be like again, to me this screams out as a chemistry problem. Because this would be a chemistry problem where you're trying to isolate one of the variables and see what happens to it when you do different things to it. So this is to me, this has always been like a really good chemistry problem. Now, here's really what it is for this thing. You're going to undo, and when we say undo, what that really means is you're going to do the opposite or do the inverse operation. So you're going to undo what has been done to the specified variable. Now, it's still solving equations, but it's solving equations with a little bit of a twist to it. We're not just solving for x. This is one of those things that they're going to give you. Sometimes they'll give you 3 or 4 different variables. You'll have an x and an a and a b and a y, and you've got to get x by itself, or you've got to get a by itself. And you can take it back to some of the equations that we were doing earlier. Going back to and here's basically what you can do back here. If you go back, just flipping back for just a second, I'll bring it back here. For this equation, what were the 2 things we did to x here? Because you got an x plus 5 and you've got x divided by 6, right? So you've got division and you've got addition. So what's the opposite of addition? Subtraction. What's the opposite of division? Multiplication. So when we get finished, we took this number and we subtracted x and we multiplied by 6. Now, in this case, it came out to be like specific where you got an answer. The difference is when you do this one, we're not going to have like just a certain number by itself. We're going to have all this other stuff that's in there. Okay, so it can look something like this. Okay, so you got capital R, just so we can keep this up here. Capital R times R1 plus R2, and that's going to equal R1 times R2. That's like a bad episode of Star Wars. R2, all that stuff. But anyway, all right, so here's basically what it is. And sometimes some of them are actually going to be a little bit easier than what you think, because for this thing, when you've got R in the parentheses, what does that really mean you're doing to R right here? You'd say that's R times R1 plus R2, right? So what's the inverse, or what's the opposite of multiplication? Just dividing, right? Yeah. So all you're going to do is you're going to take this equation that we've got to start with. And since it's R times this thing, well, to make it work out, we're just going to divide by that thing. That cancels out. Got the capital R. your answer. And you may be going, well, we didn't do that much to it. No, sometimes you don't. Sometimes to get a letter by itself, you might just add or subtract something or just multiply by something. So sometimes there's not a whole lot you're going to do to it. And this is one of those cases where you do one thing and you're in business. You're good to go. All right, let's give you another one where it gets a little bit longer. Still not too long. So for this one, we've got A times, or A equals H over 2 times B1 plus B2. Okay, now this one, we're going to do one little small change, because sometimes they give you a problem like this, because the first time I had it, it threw me off a little bit. If you get one like this, you almost have to kind of think about it or rewrite it as this, that this is H times B1 plus B2. And then it's H divided by 2. You can take this divided by 2 and spread it out so it's the whole thing divided by 2. So if they give you something like that where you've got like just the one part of the fraction, think about the whole thing being divided by 2 there. Okay, so we're trying to get this B2 all by itself. So we've got to get rid of the B1, we've got to get rid of the H, and we've got to get rid of this 2. Well, this thing is divided by 2, right? So to get rid of that divided by 2, we're going to do the opposite. We're going to multiply by 2. And just make sure you do it on both sides. So those 2's get each other knocked out there. Alright, so now you got two things. You've got H times B1 and B2, and you've also got B1 plus B2. So you've got this H multiplied, so to fix the multiplication, you're going to have to divide. So that'll knock that out. Okay, and then once you're here, pretty easy, right? It's B1 plus B2, so to get rid of that one, we're just going to have to subtract it. Now, the other side, when you get to the other side that's over here, it may be all messed up and stuff may be scattered everywhere. That's fine. You really don't, I mean, you do kind of care what it looks like. But the main thing is you're just trying to get this B2 by itself. So that's 2A over H minus B1. And that would be the answer that you're looking for there. Okay. And that's the biggest thing you got to kind of get through there is that, okay, whatever they did to that letter, I'm going to have to do the opposite to it. If I multiplied it by something, I got to divide it. If they added something, I got to subtract it. You know, so everything's just opposite of what you're looking at. All right, one more of those, and we'll just wrap up section 4. Okay. Let's go with A over B times 2x minus 12 equals C over D. Oh, sorry, we need to see here. There we go. So A over B times 2x minus 12, and that's going to equal C over D. Okay, and this one might be a little bit easier because we're used to solving for x because we've got the 2x minus 12, so it makes it a little bit easier. So we're getting rid of everything that's around the x. So same thing again. You've got x minus 12, so we know at some point in time we're going to have to add 12. You've got 2 times x. You're going to have to divide by 2. You've got it's a times this thing, so you're going to have to divide by a. It's this thing divided by b, so we're going to have to multiply by b. So you can kind of see, hopefully in the front, how it works. It's just getting everything exactly where it should be there. Okay, so first thing is, you've got the whole thing divided by b, so let's just go ahead and multiply everything by b. Okay, so multiplying by the b, that cancels out that divided by b. So that makes the right side CB over D. Okay, and you've got A times this thing. Well, if it's A times, then the next thing you're going to do is you're going to divide by A. Okay, now this one's got a little bit of a trick to it. If you've got C over B divided by D, and then you're going to divide it by A, well, if you divide it by something and then you divide it by something, just put these two divided bys together. So that really makes that CB over AD. Because you're going to divide it by A and you're going to divide it by D, so just go ahead and divide it by both of them at the same time. Okay, and then from here, hopefully it looks okay, because, you know, if you cover up the right-hand side, if you're solving for x, it's 2x minus 12, just got to add 12 on both sides. So we got 2x equals CB over AD plus 12. And then the last thing is, because it's 2 times x, you got to divide it by 2. So divide this by 2, divide that by 2, and divide that by 2. Okay, now this one's kind of the same thing here. When we took that CB and AD, if you divide it by 2, it's CB divided by AD, and then it's divided by 2. So really, it's CB divided by all three of those. So it's really just CB divided by 2, A and D. And then you got 12 divided by 2 to make that 6. Now, again, good news is there's not a whole lot of those in the homework. There's not a whole lot of those on the test. You know, looking at, I think if there's a few in the homework, there's even fewer than that on the test. So this is not one of those things where I'm going to give you 35 of these on the test. You're going to get 1, maybe 2 of these to kind of work through. One will be short, one's kind of long. So that, you know, hopefully one of them is at least kind of easy to kind of go through those. But if you can kind of get in your mind that really all you're doing is just doing everything backwards, doing the inverse operations, that's kind of the biggest thing that you want to kind of look at when you're going through that part. So that in section 5, let me just show you the basics of it here. That section 5, we're going to solve, but instead of being equations, we're doing inequalities. Which means we're doing less thans and greater thans, and less than equal to or greater than equal to. Okay, now this is more review. We're not going to get too deep into this one. I just want to go back and make sure everybody remembers all the basics on this one. If you're doing less than or greater than, if nobody's ever told you this, if it looks like an L, it's less than. If it's not, then it's got to be greater than. So just remember, less than looks like an L. This is the one that when we graph this is going to be an open circle. If you've got the bar underneath it, that means it's going to be a solid circle. And when you get ready to graph these, because you're going to have to graph some of these when we're going through this one. When you graph it, always put your variable first. Because if you do that, the arrow that you have here with your less than and your greater than, the arrow matches the direction you should shape. Okay, and again, if nobody's ever told you that, or maybe they did, maybe you forgot, that's why I always go back and try to remind you the basic little things. Because it's the little things that makes the difference when you go through this stuff. Yeah, the big stuff's important, but it's the little things that get you through all the other big things you have to do. Okay, so here's the basics. And again, going back and just picking up on it. If they give you x is greater than 4, if you have to graph this one, now, I'm not going to ask you to put 14 different points on there. Usually I'm going to ask you to do the 1 point, give me 1 point on either side of it, one value either way. If it's x greater than 4, and here's why you always put the letter first. The way that arrow is pointing, you've got to have the same arrow down here when you graph this thing. So you've got to go that way. So that arrow has to match this arrow. They both have to be the same as long as you put x first. If you don't put x first, they're backwards. So that's why we always tell you to put the x first on this thing. So all we need is an open circle at 4, and then we got to connect this circle to that arrow, so that's everything going this way. Now, if you just came out of geometry, you didn't do a lot of graphing like that. You may have done just a very tiny little bit in geometry, if anything. This was more back in Algebra 1 when you were doing this kind of stuff, probably more back in 8th grade math. So if you did connections, you should have done some of this in connections. All right, so let's go with x less than or equal to -2. -2, -1, and -3. Alright, and again, as long as you put the variable first, that arrow less than should be the same as what you're going to put here. This time you've got the bar underneath it, so I need a solid circle at -2. And just connect the arrow to the circle. Cartridge. Hey. Okay. All right. All right. Bye. Jade. Miss Bassey said she needs to see you for just a minute. One of the counselors. Counselor's office. Yeah. Just go back and ask for Miss Bassey. I'm not sure which direction she is, but she's back there somewhere. Just take the pass with you when you go. Yes. Okay, now that's the graphing that we've done in the past, so that's everything that's there. Here's the one thing that we're going to add in that just want to show you this today, and we'll come back and pick up with it a little bit more tomorrow. But they're going to talk about interval notation. This is something that you didn't do in Algebra 1, so this is basically kind of a brand new thing here. Sometimes we'll call it just IN for short. And what interval notation does is it takes the answer you have in graph form, so you're going to take the answer you have in a graph, and it's going to rewrite it using one of two different ways. If you have an open circle, it's going to use parentheses. So what we're doing the graph up here with and now here's the thing is they're still going to let you graph with open circles and the closed circles, but after you graph it, they're going to tell you to write the answer in interval notation also. So it's just one more thing they're going to ask you to do from here. The other thing they're going to ask you to do is instead of you use parentheses instead of an open circle, you're going to use a square bracket, which you don't use a whole lot. Instead of the solid circle. Okay, and let me show you just one more example of that one. We're going to give you an inequality. We're going to graph it, show you what it looks like with interval notation. And again, we're not going to get just showing you just the idea of it today. We're going to come back in and work on this some more tomorrow. But it's always good to at least show you this ahead of time so that tomorrow when we get to it, if you've got questions rolling around, we can come back in tomorrow and kind of dig through the questions and see exactly what we need to kind of look at there. So here's what it's going to be. They're going to give you an inequality. Something like x less than 7. And then they're going to ask you to graph it. And then they're going to tell you, all right, after you graph this thing, then tell me what it's going to be in interval notation. Okay, so if you graph it, again, just nothing really weird about the graphs here. You've got it going less than, so it's got to go this way. Then open circle at 7, and everything headed that way. Okay, so graph-wise, they're going to give you just a plain regular graph. They're not going to change up the graphs at all. After you graph it, they're going to tell you, all right, now tell me what that answer would be in interval notation. Now, here's really what interval notation is. You tell me the left-hand number. So you're going to need the left-hand number, and you're going to need the right-hand number. Well, we'll say hand, we'll say leftmost is really the best way of saying that. You need the leftmost number, and you need the rightmost number. So if you're going to give me two, so interval notation, you're basically going to give me two numbers. So what's the number you can go farthest to the right here on that graph? That we can actually touch. The last number we touched on the graph right here would be 7, right? Because we could put, the numbers out here. So tell me what number you circled. In that case, that's 7. You can go forever to the left, correct? So when we talk about forever, what is that? What number is forever? Infinity, right? Now, in this case, it's going to the left, so it's negative infinity. So all you're going to do is you're going to tell me I'm using negative infinity as the left number, 7 is the right-hand number, and you're just going to put a comma right there. And since we've got an open circle, they're going to tell you, all right, put a parentheses around it. And that's what interval notation is. You tell me the left-hand number, the leftmost number you can use. You tell me the rightmost number you can use. And instead of a circle, you're going to use parentheses. Or instead of a solid circle, you're going to use a square bracket. All right, one more quick one of those and we'll be done. All right, so if it's negative 10. Again, graphing it, if I give you a graph to fill in, you just give me like 3 numbers. Give me the one number you need and give me the other numbers around it, and that should be plenty. For this one, solid circle at negative 10. And then arrows here, so you're going that way. Okay, and again, all you're going to do is you're telling me 2 numbers. What's the leftmost number I can use and what's the rightmost number I can use? Well, it goes forever to the right, so that's infinity. And going to the left, you're going to stop for sure at negative 10. All right, now here's one small thing you have to add here. Infinity always uses parentheses. Now, when we say infinity, that's also negative infinity. So whether you're using negative infinity because it's pointed to the left or whether you're using positive infinity because it's pointed to the right, you're always going to use a parentheses because when the bracket means that you stop right there. So brackets means there is a definite stopping point. You have to stop at negative 10. If you can you stop at infinity? Because if you give me a number and just add one more to it, right? So yeah, you can always just go for that one. So no matter what you do with infinity, you can't stop at infinity. It just keeps going forever. So you can that one you always have to use parentheses on because there is no stopping.